All right, if you would go and have your homework out. You had a little bitty tiny handout, unless you're Scott, because yours was still on a full page, but this was all that was on the top of the page, and there was just a lot of emptiness, because that's the way it goes when I scan things. Anyway, 18 problems. We were doing 20 of them in 4 minutes for a speed drill sort of thing yesterday a couple times. We'll do that a couple more times here in a moment. Just 18 this time, and said so if you wanted to time yourself, maybe give yourself a little bit more time. Give yourself about 5 minutes to make sure they're accurate, but certainly not on the clock necessarily. Curious if anyone here did time themselves.
No.
You did? How long?
I got 3 minutes, 5 seconds.
3 minutes, 5 seconds, all right. Well, let's see the most important thing on this one. Like a test, like an exam, for instance, coming up, the main thing is accuracy, not so much speed, right? So on quizzes and tests, it's not a race, but races are fun and I like them. So we will do a couple more of those in just a moment, but let's take a look at the answers. And if you were going to hold the homework handout up so that I can see that it is completed, and not wave it around so I can't read it, Adam. Ah, thank you. All right, let's check answers. Number 1, what did you get for your answer, Joshua?
5a plus 5b.
5a plus 5b is correct. Number 2, going down that column, Lana, foot down.
4m negative 4n.
4m negative 4n. Adam, number 3.
14r negative 7s.
14r negative 7s. Number 4, Dylan.
3ab negative 6ac.
Good, 3ab negative 6ac. Number 5, Joshua.
2bx negative 2by squared.
Good, 2bx negative 2by squared. Number 6, Lana.
V cubed positive 4v.
V cubed positive 4v. All right, number 7, going down the second column now, Adam.
5c squared negative 20c.
Good, 5c squared negative 20c. Number 8, Dylan.
4r to the 4th negative r.
Lana?
R to the 4th negative r cubed.
Should have been r to the 4th negative r cubed, with or without the 1. Like, 1 could be understood, but nothing wrong with r to the 4th negative 1 r cubed. Back to Dylan for redemption number 9.
35x squared negative 5x cubed.
Great job. 35x squared negative 5x cubed. Number 10, Adam.
3x squared negative 6x cubed y positive 3y squared.
A little trouble there on the middle term, Joshua.
3x squared negative 6xy positive 3y squared.
There we go. 3x squared negative 6xy positive 3y squared. Back to Adam for redemption number 11.
X squared z positive x cubed. Wait. X z squared positive z cubed.
There we go. X squared z positive x z positive z cubed. Let's go back to Adam for redemption again on number 12.
5a squared negative 10ab positive 5b squared.
There we go. 5a squared negative 10ab positive 5b squared. Number 13, Lana.
15c to the 4th negative 20c cubed positive 25c squared.
Good. 15 c to the 4th negative 20c cubed positive 25c squared. Number 14, Dylan.
3x squared negative 12x positive 24.
Great job. 3x squared negative 12x positive 24. Number 15, Joshua.
A squared b positive ab squared negative ab.
Great job. A squared b positive ab squared negative ab. Number 16, Adam.
M cubed n squared positive 2m squared n cubed negative n to the 4th.
Good. M cubed n squared positive 2m squared n cubed negative m n to the 4th. Number 17, Lana.
4c cubed d squared negative 4c squared d squared positive 12cd squared.
Good. 4c cubed d squared negative 4c squared d squared positive 12cd squared. And number 18, Joshua.
6a squared b squared negative 20ab squared x positive 25b squared x squared.
Perfect. 6a squared b squared negative 20ab squared x positive 25b squared x squared. All right, out of 18, how many correct answers? Out of 18, how many did we get right? All 18. You had one wrong, didn't you? I thought I called on you for one and you got it.
Wait, oh wait.
Number 8.
Yeah.
Uh-huh.
Wait, what was number
I forgot. I
11?
looked
don't-
back at it.
What was number 11?
Number 11, x squared z, positive xz squared, positive z cubed.
Okay, I got 17.
17 out of 18? 15 out of 18?
I got
It's
16.
just that I
16 out of 18.
Well,
All right.
Wait, I did get number 6. I switched the V and the 4. I don't know if that was.
You did V4? Yeah, minus a point. You want to make sure you put the numbers before the letters. All right, we'll put that aside if you would, please. And I have passed back to you this handout we were working on yesterday. So Scott or other students who may be watching, make sure you go and get this out. And then take that piece of paper, and you should have already filled 2 sides of the paper, but if you fold it the other direction, you have 2 new sides available to you. So fold it so that what new side is showing. Cover column B like we did yesterday, and number down 1 through 20. Cover column B, number down 1 through 20 on your paper. Yes, sir.
My piece of paper's over there.
Adam, why did you throw things on the floor? Don't throw things on the floor. That's littering. Then you have to clean up my room after school. Not that I mind. I like the help. I appreciate it. Thank you, Adam. Number down 1 through 20. Again, the time to beat is 2 minutes 15 seconds. I think I'm trying to remember how long ago Sophie was in 9th grade. I want to say it was like 6 or 7 years ago.
Wow.
So this is a record that has stood for a while. 2 years ago, Genesis came within 1 second of that, and a year or 2 before that, Quentin had come within 5 seconds. But to get on the leaderboard, you got to be under 3 minutes. Remember, with everything perfect. Okay?
Under 3?
Under 3 to get on the leaderboard. Okay, under 4 is the goal, though, right? That's feeling accomplished at under 4. Because again, the leaderboard has probably, I don't know, a dozen names on it, and that's in a dozen years. Okay, so an average of maybe 1 person a year makes it to the leaderboard. So. Yeah, so it's not there's a reason I keep track of those names. That's a pretty significant
Who got
amount.
on it last year?
Last year,
Quentin.
no, Quentin would have been several years ago. Let's see, who was in the class last year? Nobody from last year's class made it on here.
Am I in
Yikes,
fourth
that's
place?
bad.
But we've had some years where a couple people make it. So
Am I in
all right.
fourth place?
Here we go. You will have 4 minutes. We've numbered down 1 through 20.
You always do it 4 times.
Yep. That way everybody has the same number of chances to make it on the leaderboard. That way it's a fair competition. Yes,
So
sir.
just to make sure, what order do we write this in?
Alphabetical order. Always. Yes, sir. Yep. All right. Ready? Go. Sophie finished? One minute. All right, don't stop. How many did you get done, Adam?
I don't. Let's see.
They're numbered.
I think. Well, yes, but I have to write outside, and I lost track on which one I did.
Never mind, Adam. All right, Lana and Dylan trade. Lana and Dylan trade and check each other's. The rest of you check your own. Lana and Dylan trade. The rest of you check your own answers. Let's see how we did. Check your answers against column B. And as you check each other's, maybe use a pen, mark any answers that are incorrect. Forget that, check the answers.
Oh.
Trish had 15 on the leaderboard currently. 15 in 12 years. Well, 11 years. This is year 12, so 15 in 11 years. Mark on your own paper, please, not on the actual handout, since I try to reuse these from year to year because I'm too lazy to print them again. Did you ever figure out how many you had right? Or how many you had done?
I think I did 18.
You did 18? How many correct?
Oh, I haven't checked that.
I said check your answers, Adam. I've got a 4-year-old at home who can follow directions better. Come on, man. Dylan, how many did you get right? She went 20 for 20. Wow, good job, Lana. Not fast enough for the leaderboard, but that is the best you've done so far, so we've constantly improved. That's very good.
Am I?
We're going to find out. When she's done with yours. And of course, Scott, you can feel free to send in your results if you've been timing yourself. If you haven't, time yourself on this next round. How many did he have correct?
He missed 3.
So 17, right?
Yeah, 17.
All right.
It
So
was
not
a
as
really
good.
tiny mistake.
Yeah, faster than last time, but 2 more incorrections. So Try to keep the same speed and then a little bit slightly more accuracy. All right, got results now, Adam?
I mixed one.
Out of 18, so 17 correct? All right, that would be your best so far. Good. All right, and then Joshua. So how many correct? 19 right. All right, and so more accurate than last time, and 10 seconds faster than last time, so your best performance yet as well. So good. We got one more shot at it. We've been improving each time, and we'll take one more shot. Yes.
If I made all of them right, what place would I have been?
You would have been, there would be now be 16 names on the leaderboard, and you would have been 14 out of 16. There would have been 2 people under you. Well, 2 minutes, 50 seconds. You just made it under the 3-minute mark. So, yeah. All right, one more try. Flip that piece of paper over. You were at 3:38. Again, the goal is 4 minutes. That's really the goal. It's just if you happen to be under 3, I put you on a special list.
So
but
what was I at?
you were at 3:23 and only missed 1. So that's really good. Really good. All right, number down 1 through 20 on the back side of the paper. Now we're using all 4 sides so as not to be wasteful. Try to conserve paper, save trees, that kind of thing.
Is that
save
why
the planet.
you're wanting to do it 4 times?
No, it's just it's a convenient way to do it since we're going to do it 4 times. Really, the goal is to see you personally get faster each time and more accurate each time. Right? If we only do it once, it's like, okay, I did this, but I want you to see, okay, I can get faster, I can get better by repeatedly working. And it's not that you're memorizing the answers, because I don't think anybody could memorize 20 answers.
No.
Bet you are.
If you could, you would have gotten 20 for 20, Adam.
I
And you
didn't
did
try
it.
to memorize.
Oh, I just looked at the board.
All right, here we go. We all number down 1 through 20. We are ready. We're not numbered 1 through 20. We're numbered 1 through 17. Now we're numbered 1 through 20. I have very good eyesight when I have my glasses on. All right, ready? Go.
Eagle eye.
So if you're finished. Joshua. Start checking yours, Lana. Stop. All right, begin checking your answers. And for all of you, this would be each of your fastest times yet. Other than Dylan, you were 1 second slower than last time, which is fine if you got them all right.
Wait, what did I have?
You were at 3:30, so you beat your previous time by 8 seconds.
What was I?
You were at 3:01. You just missed the cutoff, so for the leaderboard, but still fantastic job, particularly if we got them all right. So we are checking answers. All right, how many Joshua get right?
16 out of 20.
It's 16, so accuracy dropped a little bit with the increased speed. All right, keep checking his.
I think he did 17 and 16 the same.
Oh, I gotcha.
And the other ones are just like simple mistakes.
How many correct?
Missed one.
So how many correct?
Oh, 9.
19 right? All right, so you're fastest and most accurate? Yeah, great job. How many get right?
17.
So same as last time then, okay. And then Lana, how many did you get right? Got all of them right, so you improved on your fastest ever. All right, so no leaderboards this year, that's okay. I don't think last year had any leaderboards either, but always fun to give it a try and to see yourself getting faster and more accurate with this. All right, let me go and collect the handouts from you, because like I say, I'm too lazy to want to reprint these every year. You can keep your own papers and, you know, make paper airplanes out of them after school or something. I got 6 classwork problems for you on the chalkboard, so we're all giving them all to Lana.
No, I'm trying to.
Oh, you're trying to get your own paper back. I see, okay. That's true, I forgot you two had each other's papers. I was like, oh, they just love Lana and want her to have their papers. All right, so if you have space on that paper, maybe work these 6 problems on your paper, not writing the problem down, just writing the answer. Okay?
How do you do it?
Oh, sorry. It would help to have the exponent on there. That's supposed to be a cube.
Okay. Yes.
It's like, what do I do? Nothing. You just stare at it.
Wait, you want us to do it on this?
If you have room or you can get out another sheet of paper, you can do it in your notes. It's up to you. right, let's go and take a look at these together. And as we look at this first one, we're raising to a power. And when you raise to a power class, there's 3 steps.
Sign, number, letter.
Sign, number, letter. Now, if there were a positive, the exponent really doesn't matter. You're always going to get a positive. But with a negative, it does matter what kind of exponent you have. Here we have an odd power, so I'm going to get a negative. And then 6 cubed, what does that mean, class? 6 times 6 times 6, which gives us 216 when you multiply that out. And then when you raise a power to a power class,
multiply the exponent
to get
n to the 9th and to the 15th.
And do we have that answer? Negative 216, m to the 9th, n to the 15th for this first problem. Let's go down here now. This time I've got a negative to an even power class.
Positive.
3 to the 4th means 3 times 3 times 3 times 3, which is
81.
81. And then what do I get with these letters here, Dylan?
X to the 8th, y to the 20th.
There we go. How many had this answer for the second problem?
I just
Didn't even get there. Oh my. All right, questions?
Yeah, I did.
All right, let's come over here. And once again, we're multiplying 3 different monomials together. So class, my 3 steps are sign, number, letter. I've got a positive times a negative times a positive. Negative. Because there's 1 negative. That's an odd number of them. I've got 4 times 2 times 5. 40. And then what do I get for my x's here, Joshua?
x to the 6th.
X to the 6th. For my y, I should end up with
Y to the 10th.
And there is also a
Z squared.
that's kind of along for the ride. How many got this answer for this problem here? Questions on this one? All right, Lana, coming down right below it. Again, a series of, actually, let me mix this up just a little. Well, whatever. What's my sign going to be?
Negative.
Negative, just like it was last time, because there's only one of them. That's kind of boring. I should have mixed up the number of negatives here. And then we got to do 3 times 2 times 5 times 4. Ends up giving us
120.
120. And then for our letters, what do we get?
A to the 4th, B cubed, C.
Excellent job. How many have the same answer here? All right, questions on this? We come over here, and if you look at this problem, it looks a lot like this problem, except these are 1, 2, 3, 4 separate monomials being multiplied. Here we have a monomial being multiplied by a trinomial. So here we're going to have to class distribute. This is not distribution, but this is. So we're going to do sign, number, letter, but we're going to do it 3 different times. For my first sign, number, letter, what do I get, Adam?
6a squared bc.
Then for the next one, keep going.
Negative 15ab squared.
And for the last one.
Positive 12a cubed b squared.
There we go. And then for this last problem, again, it's a monomial times a polynomial. So again, we're going to distribute here. And what do we get, Dylan?
Negative 42x squared y squared, positive 28x y to the 4th, negative 35x to the 4th, y squared z.
And that is correct. Questions on any of these?
I got the last 2 at the end now.
Okay, question.
I just didn't distribute. I just
Oh, okay, do you see the difference? Okay, these are individual monomials. That's polynomial monomial distribution. All right, any other questions, comments on this? Yes, sir.
I got negative 49x to the 5th, y to the 4th, z.
Well, careful. Negative times positive is negative. 7 times 5 is 35, not 49. Yeah, and then careful here, x times x cubed, x to the 4th, and y squared has no friends, but it exists, and the z has no friends, but it exists. All right, any other questions, comments? Clear desk except for a clean sheet of paper and a pencil. 1 clean sheet of paper and a pencil. Everything else away. First and last name at the top of your paper, along with today's date, which is 10/6/21. 10/6/21, today's date. And this is quiz 9. First last name at the top of your paper along with today's date, which is 10/6/21. Taking quiz 9. Quickly, Lana, getting on a sheet of paper. Scott already has one.
you mail all his work?
Mm-hmm. Yeah, we shipped a big package of quizzes and tests to his mom overseas. It was expensive.
It probably.
All right, let's take a look at the quiz very quickly together. 1 through 3, answer those questions. And then for 4 through 11, you're multiplying, so do what's indicated there. All right, be sure to use the quiz copy as a cover sheet. I'll get started.
Today's the 6th, right?
10/6/21, today's date, yes. Just a couple more minutes to be finishing up. One more minute to be finishing. Collect those from you at this time. And if you would, go and take out your notes. Take out your notes. We have talked about multiplying monomials together. We have talked about multiplying a polynomial by a monomial. So today let's talk about multiplying a couple polynomials together. Next section of notes, multiplying polynomials. And again, when I use the term polynomial, I'm specifically referring to things that have more than one term. Okay, so binomials and bigger. I want to start though, and you don't have to write this part down, just get the heading in there for now. I want to start by taking you back to your elementary days. Back when you were multiplying something like, you know, a 3-digit number by all of a sudden a 2-digit number. Whoa, it was big stuff, right? It looked scary and frightening to you as a little 4th grader, I think, maybe 3rd grader, but I think a 4th grader. Anyway, and the teacher told you, we're going to start and we're only going to focus on the ones place. And we're going to multiply just like we did earlier. So we already know how to multiply a monomial, a single digit by lots of digits. You multiply in order by place value, right? Well, ignore the 2 for now, and we're just going to multiply the 1. And 1 times 2, class?
2.
And 1 times 1?
1.
And 1 times 3?
3.
And then the teacher said, now we're going to ignore the 1 and we're going to focus just on the 2. But it's not really a 2 because it's in the tens place. So what number is this really? A 20, right? So what we're going to do though, we don't want to try to multiply by 20. So if you put a 0 here, then you can, as you multiply by 2, it's as if you're multiplying by 20. So we're just going to put a 0 here. Then we're going to multiply 2 times 2, class? 4. And 2 times 1? 2. And 2 times 3? 6. And it's very important, class, that you keep your numbers lined up nice and neatly. And then we're going to add what we call our partial products together. 2 plus 0.
2.
And 1 plus 4.
5.
And 3 plus 2.
5.
And nothing plus 6, of course, is
6.
And make sure you put your comma so it makes the number easy to read. Do y'all remember learning that? Now, they probably taught it better than that because I'm certainly no elementary teacher, but that's kind of the gist of it. And again, the reason for all of this going this direction was because of carrying in place value. But there was no carrying. So she could have done the exact same problem lined up this way. She could have started with the 2 and multiplied, class, 2 times 3.
6.
2 times 1.
2.
2 times 2.
4.
And then instead of putting a 0, which essentially shifts things over this way, we could shift things over that way. Ignore the 2 and multiply the 1. 1 times 3.
3.
1 times 1.
1.
And 1 times 2.
2.
And when you add the partial products together, you still get the same answer because there was no carrying necessary. And what we're going to do in algebra, we always work left to right. But let's suppose instead of a 312, suppose this was a 3x squared plus 1x plus 2. And suppose instead of a 21, this was a 2x plus 1. I want you to write this problem in your notes. We're going to take that same basic approach, though, except we're going to go left to right. But just like you couldn't multiply 21 all at once, I mean, that's just hard, right? No, take it one digit at a time. Whether it's the 1, shift, then the 2, or whether it's the 2, shift, and then the 1. So we're going to multiply just the 2x all the way across. We're essentially going to distribute the 2x. We're going to ignore the 1 for now. 2x times 3x squared, class.
6x cubed.
Then 2x times 1x.
2x squared.
Then 2x times 2.
4x.
And then we're getting ready to multiply the 1, but we're going to shift over. I'm not going to put a 0, but I am going to put a little, stair step if you want to call it, just to shift things over so that we get like terms to line up. Here we were trying to get like place values. Here we just want like terms. So we're going to ignore the 2x. I'm multiplying the 1 now all the way across. 1 times 3x squared. 1 times 1x.
Positive 1.
And 1 times 2.
Positive 2.
And when we add our partial products together, notice the answer, 6x cubed, positive 5x squared, positive 5x, and of course, positive 2. There's the 6, 5, 5, 2. It just happens to be with x's in descending order. Now, the descending order is important because it's the descending order that allows the like terms to very neatly line up, like I've alluded to before, the silverware drawer. All of the x cubes in one column, all the x squareds in the next, all the x's in the next, and all the nothings in the next. Nice, neat, descending order. Do you see how, as I said at the beginning of the year, algebra is an extension of arithmetic? We're not doing anything different than we did in arithmetic class. We just happen to have letters infused into the problem. Does that make sense? Write this problem down, if you would, on your paper. X plus 5 times x plus 2. X plus 5 times x plus 2. Since everything in algebra works from
Left to right.
left to right, thank you, Joshua, we're going to start by multiplying the x, not the 2. And we're going to multiply straight across. X times x, class?
X squared.
X squared, and x times 5.
Positive 5x.
Positive 5x. We always put things number first before letters alphabetical.
I always get confused. When is it 2x and when is it x?
X plus x is 2x. X times x is x squared. 1x plus 1x equals 2 x's.
Yeah.
X times x, x squared. All right, so we're done with the x. Shift over. You can scribble out the x if you want to. Let's multiply the 2. 2 times x. 2 times 5. 10. Don't overthink this now, okay? And then we're going to add the partial products together to get what answer, class?
X squared positive 7x positive 10.
There we go. And remember, we are adding the partial products. So don't try to multiply these together to get like a 10x squared or something weird. You're just adding the columns together. Write this one down. 3a negative b times 2a positive 7b. 3a negative b times 2a positive 7b. We're going to start by multiplying the 2a all the way across the top factor, left to right. What do I get, Lana?
6a squared negative 2ab.
There we go. And now that we're done with the 2a, now it's time to multiply, Joshua, the
7b.
7b all the way across. But before I do, let's
Put the chair thing, move everything over.
there we shift it over. So we multiply the 7b across left to right to get
21ab, negative 7b squared.
and then what do I have to do now, Dylan? Add the partial products together, right? And what do I get?
6a squared positive 19ab negative 7b squared.
And there we go. Questions on that? Start to get the feel for this. Let's do one more before we wrap it up. Let's do one more before we wrap it up. Write this one down if you would, please. X plus y minus 4z times 2x negative y. This one's got a little bit of an interesting twist to it, but for starters, we're just going to do what we know to do, Adam. We need to start by multiplying the
X.
no,
Wait, the 2x.
all the way across. What do I get, Adam?
2x squared. 2xy.
Positive 2xy.
Negative 8xz.
There we go, and I'm done with the 2x, so I can scribble it out. Then we need to shift over. And we're going to now multiply, Adam, the
Negative y.
let's multiply the negative y all the way across. What do we get?
Negative y squared.
We're multiplying all the way across.
Right. Negative xy.
Good. Or I'm going to write the 1 in there, the negative 1xy. But then when we multiply the next things, watch class, we get
Negative y squared.
negative y squared. That doesn't go under here. So I'm going to have to leave a little bit of a gap and put my negative y squared. Do you see that? Yeah, when there's multiple letters involved, that way happen, stay with me. But we're not done. Okay, we multiplied the negative y times the x, the negative y times the y. Now we need to multiply the negative y times the negative 4z back to Adam.
Positive 4yz.
But again, that doesn't go under here either. That goes at the end, I guess. And so we add the partial products. There's not actually that much to have to add. Most everything is in a column by itself, except right here. What will we get for our answer, Lana?
2x squared, positive 1xy, negative 8yz.
XZ.
Oh, yeah. Negative y squared, positive 4yz.
And there's our answer. Now the good news, this is not on the exam on Monday. I just wanted to introduce this to you. We're actually going to pick this concept up after the exam. Okay, so we will be reviewing the next 2 lessons in preparation for your exam. Exam coming up on Monday in lesson 43. I do have a short homework assignment for you to do this evening so we can stay on track for that exam. And that is page 198. Page 198. Do the review, numbers 1, 2, 5 through 8. So just 6 problems for homework. Very short assignment. This keeps us on track. A little bit of review in preparation for the exam. Page 198. The review, numbers 1, 2, and 5 through 8. Have a wonderful rest of your day, and you are dismissed.